Update from myself really. So I'm a workstation technologist for Lenovo. So I look after our workstation portfolio for UK and Ireland, and basically want to show and highlight to you really on how you can enhance the performance of your workflow, not just looking at the software applications, the plugins and all the great technology you've heard about today, but how the workstation hardware that underlines all of that is obviously very, very key and important to yourselves. Right, so information technology, key thing really, it's intelligent technology. So workstations today are doing a lot more than they ever have done. People are moving into all realms of physical-based rendering, obviously the robotics, the virtual reality, point cloud scanning. It's more and more important than ever now to make sure you've got the right hardware underneath your desk. So we're looking at really the latest innovations, intelligent engineering really, to look at how these can save you money, and actually the outlay cost of any new hardware can be recouped very, very quickly indeed. So we're looking at sort of real-time return on investment in the weeks, not the months, so making sure the ownership of these products over 2 or 3 years or more obviously makes perfect sense. So realistically, the cost of any decent workstation today, if any one of you in here, is cheaper than that daily Starbucks that you buy on the way in. So if you can justify the Starbucks, there's no reason why you can't justify the workstation. So hardware really, from an IT perspective, it's boring, it's expensive, it depreciates, so no one's really interested, but it's the most important part of any digital workflow. So your IT guys out there that may be interested in providing you with just a box to get the job done, doesn't really appreciate how actually the pain points can really, really affect what you're doing. So out of here, who has control or influence, obviously, in the decision making around any workstations or IT investment? Quick show of hands. Okay, not many of you. Anybody here knows they spend less than £1,000 on a workstation? No? Less than 2.5? More than 2.5? More than 5,000? Well, okay. How much do you guys spend on hardware? Yeah, Lord. Right, but essentially, it's not what you spend, it's how you spend it. So anyone can smash a walnut with a sledgehammer, but thrown in with a blank check to try and find a problem, it's not always the best way to go about it. So it's not what you spend, it's where you spend it in the workstation. So there's lots of changes around CPU, memory, graphics, storage, all this changes on a weekly, sort of a monthly basis. So I wanted to highlight and give you guys really the sharpest tools to go out and make those decisions. So making the right choices. It's not as simple as it sounds. So the basics of computer hardware, this is about as complex as it's going to get, so I'll try not to bore you, but essentially this is how a computer's built, from your system hardware, noughts and ones, your BIOS, system drivers, Windows operating system, your OpenGL, your DirectX, your graphics driver, and then we have your CAD applications on top. So that's pretty complicated. When you start looking at the number of possible workstations, the number of possible graphics cards, the number of versions of Windows, the number of versions of software applications you run, you're talking millions of possible configurations. So it's constantly like hitting a moving target. So for you guys to try and get that there and choose the most appropriate hardware for all those different scenarios, I'd say good luck, because even I struggle and I do it for a job. So for me, confused, I know I am. So the way it looks at it, some key facts really. So no software is created equal. Software is normally split into being single-threaded or multi-threaded. Single-threaded software, typically CAD applications, they're driven by the clock speed of the processor. The multi-threaded software, things like 3D rendering and simulation, is multi-threaded and can tap into all the CPU cores that you have. So the two opposites, it's like two sides of the same coin. You can never get both of those together. So CPU speed is really, really important, and it's not just about the initial bullet points you see on a sort of a speeds and feeds chart. You have to look under the skin to make sure you've got the right processor, the right cache, the right clock speed, and the right sort of features built within it. Don't overestimate the use of memory. Memory is quite cheap. It's more expensive than it has been, but essentially it's a cheap way of resolving certain issues. And typically it's the second largest bottleneck that you'll find within any workstation today. And then graphics. Graphics do a lot more than just display pixels these days, from helping you render, from delivering the VR experiences in the way that you need to. So it's CPU, memory, and graphics are kind of the key three things you need to look at. And therefore, I think cheap can be very, very expensive. So those of you spending £1,000 out there, that's great, but it's all relevant to what your workflow is. What applications you're running, what does your software stack look like, how complex are the projects you're trying to undertake. So processors. Intel, key for CPUs these days. Always look for the Intel Xeon CPUs. There's two types of brands, Intel Xeon, Intel Core i7. Some are consumer-based, some are more workstation-orientated for the enterprise market. The Intel Xeon CPUs typically have a faster processor clock speed, they've got more memory, they're more reliable, they're used in sort of server type environments, and they have a feature called ECC memory, which is error correction code. Anybody here know what ECC does? Anyone hazard a guess? Nope. Okay. So ECC actually prevents memory crashes. So solar radiation from the sun will cause your systems to have memory errors and they will crash. It's not a case of if, but when. And the more often you see memory crashes, the more solar radiation there is. Once you've had one memory error, you'll get a second and a third, and it kind of snowballs out of control. So the use of ECC memory is quite key to make sure your workstations stay rock solid, stable and reliable, which is key, I guess, to any decent sort of production timescale. Look at one or two processors. So some of our workstations can take 2 CPUs. So for those doing things like CPU rendering, the more processors, the better. But again, those of you looking at CAD and design and engineering workflows that don't use multiple CPUs, then look obviously at single CPUs. So I've put 2 scenarios there. Dual 6-core CPUs versus a single 8-core CPU. Both of them have around the same price point, but obviously some of them are much faster than others depending on what type of work you're doing. Choose the right balance of CPU clock speed. So again, clock speed's always normally quite expensive. When you start adding in lots and lots of CPU cores, that gets more expensive again. But some people obviously think, well, what I might do is buy a dual CPU capable machine, fit one CPU, and then I'll come back and add the second CPU later. It's quite a common request that come in from customers and opportunities we deal with, but it's a complete false economy. So I wouldn't really recommend anybody look at adding that second CPU later, because it will never happen. What you'll find is it's quite hard to source the parts as and when you need to, trying to find them as a matched option, so you get them as a plug and play, easy upgrade. So we would recommend that you buy the most appropriate solution as a complete build in one, rather than try and do sort of a semi-upgrade later on in its life. Any questions at that point? No? Great. So Turbo Boost. So Intel have a feature within their CPUs called Turbo Boost, and with a new feature called Turbo Max. And I wanted to highlight it to you because it's one of the key things that can drive the performance in all the applications that you run. So always look at workstation processors, and Turbo Max and Turbo Boost is a key feature within these. What it enables you to do is a much faster clock speed for when you need it. So it's like an on-tap resource that you can turn on and off automatically when you need to do so. So your average CPU here, so look at this processor here, and this is your average 4-core CPU. It runs all 4 cores at 3 gigahertz, which is perfect when you're running all 4 cores. If you're using something like a Revit environment, in the design in the viewport window, that's only running 1 core. So what it can do, when you use 2 or maybe even just 1 core, it will boost the clock speed from 3 gigahertz all the way up to 3.8, like a dynamic sort of overclock within the CPU itself. And then using additional software on top, a special driver from Intel that can actually boost now to 4 gigahertz. So we do workstations that can natively run at 4 gigahertz, delivering the fastest sort of Revit and a 3D CAD experience that you can buy. And it works within the normal, what we call power and thermal window of the workstation. So hasn't got flashing lights or water cooled, it runs air cooled, it runs out of the box, and it delivers the fastest application experience that money can buy. And it's built in, there's no huge premium you pay for it, but it's a feature within the workstation CPUs that are available today. Memory. So memory is quite expensive at the moment. It has changed. It obviously will fluctuate within the industry. But I wanted to highlight really that it's not just about the capacity of the memory, it's the type of memory you use, the size of it, the size and what we call the rank of the CPU and the memory, its speed within the unit and the number of channels. So the workstation portfolio that we have has a number of different options. And within that portfolio, we can do dual or quad channel memory. So the example there is if you have a system with dual channel memory, you populate memory in banks of 2. So if you want 16 gigabytes, you fit 2 8s. In the quad channel machines, if you want 32 gigabytes, you fit 4 8s. If you don't match the memory to the channels, you will have imbalanced performance. The capacity will be there, so you can say, great, I've got my 32 gigs of RAM, but actually you can't access it properly. So it's like having a motorway with just 1 lane at 100 miles an hour versus 4 lanes at 70 miles an hour. You can transfer a lot more traffic when all the lanes are populated properly rather than just shoehorning everything via 1 lane. So always worth looking at not just the amount of memory you go for, but how it's configured. Sometimes it can be cheaper to actually go with a larger number of smaller capacity modules that actually deliver better performance. So the key thing really is optimize, optimize, optimize. Again, it's not what you spend, it's where you spend it and making sure you're spending it in the right areas. Graphics is something I wanted to cover. Quick show of hands, who here uses an NVIDIA graphics card? Okay, who uses an alternative graphics card? Anyone brave enough to put their hands up? No, didn't think so. Right, okay. So obviously NVIDIA, so we partner with NVIDIA and we use the NVIDIA Quadro range of GPUs, industry certified for every single major application within this industry. But the portfolio is quite large. It ranges from $150 to $5,000 and $6,000 at the top end. So where do you stick the pin? On speeds and feeds, looking at the memory and the capacity. All the graphics cards are different, and it's knowing which graphics card to choose. So helping you to choose really, we obviously recommend how large or complex are your 3D models. You're doing sheds or you're doing large commercial projects, because everyone can use Revit for different size projects, and depending on the number of polygons and the number of pixels within those scene files, you'll need a more powerful graphics card that has more frame buffer, more memory, and a faster processor within the GPU. Look at the screen resolution and the number of pixels. Is anyone here using 4K? Quick show of hands on 4K? No? Okay. The number of monitors. So who here is using more than 2 screens? More than 3? Just the 1. Okay. Key thing here looking at 4K is kind of the next buzz topic. Everyone's looked at it or investigated it. A lot of our new monitors now are coming out in a 4K resolution. It's a great way of getting more and more pixels on the screen. But what people don't realize is the graphics card is now driving 4 times the amount of pixels. So going from that one monitor at full HD to a 4K screen, that little graphics card you've got is now working 4 times as fast. So you typically have to look at maybe the next graphics card up in the portfolio to make sure that you can get the same performance driving all those pixels. Again, frequent model rotation. Are you working from a static view, or do you do a lot of animation? Do you navigate around a lot more in the viewport? By using things like the physical-based rendering, by adapting that within the workflow, you can now cut stages out. You can work a lot more efficient. But if you don't have the graphics card to back that up, then essentially those sorts of features that are new, obviously built in within the new software, can start to become cumbersome and maybe even not used at all. Color accuracy. Anybody here interested in color accuracy of the models that they're working on? The different sort of shades of color within the systems? No? So Quadro graphics can support 10-bit color. So typically your average, you're that 30-inch monitor that you may have on your desk. It's great, it's got such a wide viewing angle, but the color accuracy of that, when you view it from different angles, the reds will become pink or purple, and you're not really sure what's working. So when you work with a heavily shaded model, sometimes obviously the quality of the graphics card beneath you isn't capable of driving that experience properly. So make sure, again, you look at whether the graphics cards can support 8 or 10-bit color. High frame rates, so virtual reality is a great example here. Who here is looking at virtual reality at the moment? Okay, who here has had a bad experience with virtual reality? Okay, I can pretty much guarantee that's down to the graphics card, but I'll come up to that in a moment. And then ray tracing, GPU rendering. So who here is using the graphics card for more than just displaying graphics? And using V-Ray, that sort of thing? Yeah. So again, the GPUs have got thousands of cores built into them now, so they can do real-time rendering within the viewport without the need to outsource. So essentially, it becomes a lot more efficient to use, but it means your graphics card is typically now spec'd and configured for a different purpose. So whereas you may have had a mid-range card for your standard CAD workflow, you can now look at a high-end GPU because it's essentially becoming a built-in render device. So again, making sure you've got the right size card, the right size graphics memory to support that rendering is obviously key. Advanced lighting effects as well. And again, how many different software apps? So each of those questions is valid for each software application you run. Each software application can use the GPU differently. The more modern application, maybe coded a little bit better, can make more modern use of the new cards. But it's very, very important to make sure that you select the right card for the right workflow. So from NVIDIA, obviously they have a wide portfolio of cards. We're currently here, 2016-17, with the Pascal architecture. So their workstation graphics cards at the moment, that's a brief portfolio. They all start with a P, P for Pascal, and we range from the P400 entry level on the far end to the new P6000 and GP100 on the top end. Where you guys need to basically kind of sit is about here. So everything sort of P4000 and above can do what we call Pro VR, and everything sort of P2000 and above is recommended for those sort of mainstream sort of 3D CAD workflows. Same for the mobiles, everything sort of P4000 and above is Pro VR ready, but we have the full spectrum there of cards available depending on the size, the form factor of the laptop in hand. So key thing with VR, you always have there's 2 ways of viewing VR, a bad way or a good way. If you've had a bad experience with VR, it's typically because the workstation, or more importantly, the graphics card, isn't capable of delivering the experience that you need. So looking at your average full HD or 65-inch projected TV, it needs to run 30 frames a second and 60 megapixels a second throughput. So any graphics card can do that. Hey, my smartphone can do it. But essentially, when you start putting a HTC Vive, a head-mounted display in place, at that resolution, you need to run 90 frames a second. Anything less than 90 frames a second, then you will feel nauseous. You'll lose out within that experience. The VR experience is very, very poor. Moves up to 450 megapixels per second. So that's 7.5 times more throughput that graphics card needs to do, just because you've enabled that VR tick box and all of a sudden, put the headset on. So it's a lot more than just going to buy a headset from PC World, plug it in, and expect it to work. You need to make sure that the graphics card is built to handle that. So the new Pascal series of cards from NVIDIA are built to handle VR significantly better, and anything P4000 or above can drive these types of workflows with ease. So the key thing is latency. So what we call sort of, motion to photon. So you have your head-mounted display on the left. You move your head around, you move around within a tracked VR zone like we have in the demonstration zones outside. It moves to the CPU, it then goes to the graphics card, and then it feeds back out to that head-mounted display. If it does that in anything more than 20 milliseconds, and you put the headset down because you feel sick, and you constantly have to have that 20 milliseconds or less all the time. And that's where NVIDIA Quadro cards come in, because they're guaranteed throughput, guaranteed frame rates, no matter what type of workflow you put through it. And it's the stability of that image, the stability of the experience that you get. Another key thing we have is VR SLI. Anyone know what SLI is? Okay, scalable link interface. So what you can do, you can link two GPUs together as one sort of hypersized GPU. And what you can do with VRWorks from NVIDIA is actually have each graphics card to power each eye within the headset. So when you have especially complex, very, very dense, very, very high fidelity VR experiences, and maybe a single GPU still can't cut the mustard, you can actually plug in two GPUs, link them together, and then using VRWorks actually have the output programmed one eye. Your left card can do the left eye, and the right card can do the right eye. So a really easy way to scale that experience to the highest possible levels of quality. So moving on to storage. So anyone here who is not using an SSD today? Good. Right, so within the workstation, typically there's two types of storage. You get spinning hard disks, the old sort of hard disk drives, and the new solid state drives. But there's actually 7 different types of technology. So it's not uncommon for workstations, if anyone's here using a workstation maybe 3 or 4 years old, is to have a mixture of those types of technologies in the box. And some people have views of where the pros and cons within each one. But the key thing for us is the bleeding edge technology today. So without boring you with all the details, PCI Express SSDs are here to stay. They're significantly faster than anything else in the market. And just as an example, this is the average hard disk from a workstation which we would have supplied 3 years ago. Bigger bars, obviously better. On a good day with the wind behind you, we can throughput data at about 150 megabytes a second. Moving up to the new technology, SAS or SCSI hard drives from 3 years ago, you go to 200 megabytes. We then move up to the more modern SSDs at 300 megabytes, maybe even 500. But the new drives we're using today actually top out at over 3,000 megabytes a second. So loading in your data is extremely fast, extremely efficient, and you pay practically little or no premium to get that technology. So any modern laptop or desktop workstation you're looking to invest in today, we would heavily recommend you look at the PCI Express storage. And balance your storage. So again, SSDs can be expensive. If you want terabytes of SSD storage, it's going to cost you a lot of money. But you can mix different types of technology within the workstation. So it's very common to have the very fast SSDs to hold your Windows operating system, and then your application installs. You may have sort of a cache or a scratch disk space, depending on your project data, that can then be maybe PCI Express SSDs or normal SSDs. And then your raw data, when you need terabytes and terabytes of data, if it's not stored on a sort of a storage network or a file server, you can actually hold it locally with more of the spinning hard disks and creating new performance and redundancy as a whole. So again, balancing the performance of where you need the data, how quickly you need to access it, and whether you need security or redundancy built in. So the results really, an equilateral triangle. So your budget can vary I mean, for me, the price is what the correct solution costs, so a budget needs to kind of be defined based on what the project is. But if you've got the size and complexity of your project, therefore you can define what type of graphics card you need to go for. You're doing GPU rendering, you're doing VR, and then within your budget, you need to match the processor, the memory, and the storage to suit. It's pointless having the best processor in the world if you've put crappy memory and not enough hard disk space or storage with it. It's all about finding that equilateral triangle. And then beyond the hardware, so obviously we use Intel CPUs, we use NVIDIA graphics, and we use Samsung SSDs, same as everybody else. What we've tried to do is think outside the box and deliver an experience that goes beyond just those CPU memory and graphics. Everybody can benchmark the same, but why would you look at something different? Why can you try and extract more performance? So we've developed a number of software tools. These are complementary, so they run alongside our workstations, and they have £0 price tag. You can download them free from the web. And Lenovo Performance Tuner can actually enhance your workflow. So what it will do, if you're using more than one software application, so if you have AutoCAD, you have Revit, you may have some 3D Studio Max, you may have some 3D rendering tools, lots of plugins within that workspace. Typically, some are multi-threaded, some will single-threaded, some will need different graphics capabilities than others. So what we can do with Lenovo Performance Tuner is actually select profiles based on those applications you have installed and then tune the workstation accordingly. So when you move from AutoCAD to Outlook or Excel into Photoshop, then out to Revit and then out to 3D Studio Max, it can change the look and style of the workstation in the fly in real time and actually deliver you as much as 20% more performance within a standard CAD workflow. It's a really easy tool to install. It just makes a fast workstation even faster, making sure you are wringing out absolutely every piece of performance that's available to you. And I wanted to highlight some items. So we launched this product at Autodesk University last week. So this is my Steve Jobs moment. But essentially, this is the world's smallest 3D industry certified workstation. So it's 1 litre in size. And what we're able to do now is deliver a very, very fast, capable workstation product in a tiny 1 litre chassis. So this is the world's smallest professional workstation. It's very competitively priced, but essentially we've designed it to put workstations where you wouldn't normally put a workstation. So this can be VESA mounted behind a monitor. It can be mounted remotely in the ceiling. Alt and P from any keyboard will power it on remotely, so you can start converting projectors into sort of Revit design review type meeting rooms. But it can support a phenomenal specification for something so small. So it's quad-core, i7 Intel CPUs. We've got NVIDIA Quadro graphics, we've got 32 gigabytes of memory, and it can drive 6 monitors. We call it the Tiny, so it's our P320 Tiny. I'll hand it around so everybody can take a look. But essentially, it's extremely small. I would like it back, sir. We know where you all live, so don't worry. But essentially, it's our smallest possible workstation, and it shows how Lenovo have been very innovative in how we've packaged products to deliver what the market's asked for. Typically now driving augmented reality, mixed reality, or just 3D design or concept reviews. You're doing demonstrations in front of customers. Lugging around a large laptop can sometimes be quite cumbersome, but this can now put a workstation in various different scenarios, from driving manufacturing machinery right out to just that minimalist architectural office where you want to make sure things are much smaller and lighter. We actually have these out on the booth, and they're driving some of the demos, I think, from Cityscape as well, so you can see the sorts of raw performance that these types of platforms can do. We've also got our ThinkPad P71. So this is the industry's first Pro VR ready professional notebook. So it's 17-inch. It's not the thinnest notebook we do, but essentially it's extremely fast. The fastest, most powerful, most technically advanced laptop that money can buy. 4.2 gigahertz processor clock speed, so it will out-trance most desktop workstations that you'll have today. 15 hours of battery life, 12.8 on a standard day, 15 hours if you optimize it. But essentially, NVIDIA Quadro graphics, it can do virtual reality on the move. So the MX3D demo in the corner out there today has been driven purely by our ThinkPad P71 laptop. So anyone looking at raw performance, the best of the best, and want to have something that's mobile and portable, then definitely take a look at the ThinkPad P71. And then our P320 Tower. So I mentioned the Xeon CPUs earlier. So this is a workstation from us that we've developed to be a workstation at the price of a desktop. So those of you with limited budgets or short production timescales, we've developed the fastest Revit sort of 3D AEC box that we've ever created. So it's 4.5 gigahertz. So the turbo boost feature that I highlighted earlier on in the slides is actually now 4.5. So it's significantly faster than anything else that we'll use today, but it's in a small, compact 25-litre chassis and can run the NVIDIA Quadro P4000 graphics. So as a platform with SSDs and a very, very reasonable price tag, this is the fastest, most powerful robot box that we can do. So whenever you're looking at something that can maybe save you significant amounts of time, this works out at sort of £1.50 a day. So again, a very cheap coffee, but essentially something that can help you guys save significant amounts of money in the long run. And that's my slides. Any questions?